All right, I'm going to apologize for the loud background noise. For some reason, my students are very chatty on this Friday. No, it's fine. It's only a video for the entire world to hear. Okay, so 1A says find the arc length of a circle with a central angle of 160 degrees and a radius of 4. Okay, so if this is the information that you are given, then we should be using the proportion that deals with degrees. Okay, which is of course arc length over circumference, which is 2 pi r, equals the degree that you're given over 360 degrees. Okay, if we're given a degree in our problem, we have to use a formula that involves degrees, or you could convert your degree to radius and use that formula. But because we're given, let's practice the degree proportion since we're given a degree. So we would solve this by multiplying everything here by 160. 1280 pi divided by 360. So if we need to reduce this, right, we can clearly divide out the zeros, and 128 and 36 both have a divisor of 2 for sure. Maybe more. Yes, more. 128 divides by 8. 36 doesn't divide by 8. Let's see what it does. Okay, 4 is the greatest divisor, so we can reduce this to 32 pi over 9 inches. Remember, this is the length. The lengths are in inches. So now if we type this into our calculator, 32 pi divided by 9, that's approximately 11.17 inches. Okay, so that's as a decimal approximation. This one is an exact value. So depending on what you're asked to find, exact value is in terms of pi, or a decimal approximation as, of course, a decimal. Okay? All right, so that's if we have a degree as your arc length. Okay, 2A. We're still trying to find an arc length, the length of the arc, with a radius of 10, but now we have our angle in radians. So you can do a couple of things. You can convert this if you want to 225 degrees and use the ratio, or we could use the formula that the arc length equals the radius times the angle in radians. Okay, so if we have a radian angle, then this is the way to go. Okay, as long as your angle is in radians, then the arc length, which we're calling S, equals the radius times that angle in radians. So it's a real simple formula if we have radians. So 10 times 5 is 50. Of course, 50 pi divided by 4 would reduce to 25 pi over 2. Okay, so if we have a radian angle measure, this is the formula that we want to use. Arc length equals radius times angle in radians, right? So don't go to 225. It's great if you've memorized that, but there's a lot of work to convert from radians to angles. Just use the formula that's involved in radians. So if I type it into my calculator, 25 pi divided by 2, I get an arc length of 39.2699. And our units are feet.
Well, what does S stand for?
S stands for, what do you think S stands for? What are we asked to find? Arc length. S is, R is radius, theta is angle, so the only other thing that this could possibly be is arc length. Yes, S stands for arc length. Okay, let's move down here and do 3. Now we have an area of a sector. Remember, this is a slice of a circle, like a slice of pizza. So we're looking for what is the area of this slice. So there's a formula for that also if we have radian angle measures. And that's 1/2 of r squared times theta. Okay, now this formula is of course derived from your proportion where you have 2 pi as your circle total, right on the bottom, not 360 but 2 pi. So 1/2 r squared, 20 is our radius of 20, times our angle of 5 pi over 8. Okay, so there's a couple things to do, right? We're going to square 20. 20 times 20 is 400. We can do 400 divided by 2 is just 200. 200 times 5 is 1,000 pi over 8. And I'm pretty sure that can reduce. We can divide 1,000 by 8 and get 250 pi divided by 2. Okay, so when we put that into our calculator, that comes out to be approximately 392.699 square millimeters. Right? That's an area. Our area is always a squared unit. So if we have a theta for our sector area, the formula is 1/2 of radius squared times theta. Okay, so now try 3. Okay, so this problem, our omega, is equal to the angle of rotation. Actually, probably not. That's not what we're using here. Okay, we have omega is 200 revolutions per minute, every minute. How far does the wheel roll in 10 seconds? Okay, so first let's figure out how many revolutions happen every minute. So if we divide 200 by 60, right, 200 revolutions per minute. Let's just do this right. 200 revolutions per minute times 1 minute over 60 seconds. 200 divided by 60 is 3 1/3. So this wheel rotates 3 1/3 rotations every second. Okay? 3 1/3 rotations every second. So if the diameter is 10, that means, or 20, that means we have a radius of 10. Okay? So if it rolls, how far does it roll with 1 revolution? Right? So 1 revolution equals 2 pi r, right? That's the circumference. The circumference of the circle is the distance around the outside. So if our wheel was rolling, it would roll 20 pi inches every second. It would roll 20 pi. Where are we getting this from? Okay, let me tell you about the wheels on the bus. Okay? So here is the point. Here is some points on the bus. Right here. Okay, so this is the ground where the wheel is rolling, and the wheel is going in this direction. Okay, so as the wheel rolls, this point, of course, goes around the tire, right? And I wish I had it as an action, but it would roll 1 circumference. Okay, all the way around the circle is 1 circumference. The circumference of a circle is 2 pi r. So every time this wheel rolls 1 time, it rolls 20 pi inches. because it has a radius of 10. Okay, if we follow this point around the circle as your circle rolls, right, and we're measuring, so now this part is here. Anyway, it's 20 pi inches is the distance that it covers. What is 20 pi? 20 times pi is 62.8316. So every second, our wheel is rolling 62.8316 inches. Okay? So that's the distance that it rolls in 1 second, right? The circumference. The circumference of your wheel is the distance that it rolls. So if I take my circumference and times it by my revolutions per second, 3.333333333, I get 209.4395 feet every second, right? That's a pretty fast rotating wheel. I don't think that's actually true. So this is how far it rolls every 1 second. 3 revolutions per second, 62.8 inches every revolution gives you 209 inches per second. Dang. And then we multiply that by 10. Wow. This is a wheel on a spaceship doing 2,094 inches every 10 seconds. Right? Probably not earthly feasible. But mathematically, right, this is a fake world problem, clearly, like almost all math class problems are fake world. But it's just so we can practice the math. Holy jeez. Okay, 5a says a disk rotates through an angle of 16,200 degrees. So that's right, how many times it spins in 30 seconds. Okay, what is the angular speed in revolutions per minute? So angular speed is omega. Omega equals the angle divided by the time. Okay, that's how we calculate angular speed. So we're told it rotates through 16,200 degrees in 30 seconds. Okay, so 16,200 divided by 30 is something. Okay, but we don't want it in degrees per second because that's what our units are right now. We want it in revolutions per minute. Okay, so we have to change our degrees into revolutions and our seconds into minutes. Okay, so that's our next thing. To change from degrees into revolutions, we know that there is 1 revolution is 360 degrees. Okay, so that cancels our degree units on top so that we have revolutions. Our next step is to change seconds into minutes. And since we have seconds in the denominator, we're going to put seconds in the numerator. 60 seconds equals 1 minute.
But it's 30 seconds.
So our 30 and our seconds cancel out. So now we slap this all into our calculator. Everything in the top. 16,200 times 60. Okay, that's 972,000. Maybe I'll write that down. 972,000. That's our numerators. And then I have 30 times 360. This is my denominator, 10,800. So if I do 972,000 divided by 108,000, I get an angular speed of 90 revolutions per minute as my answer. Okay, let's look at rotating at a rate of 600 RPMs.
Good morning, Hawks
Okay,
Nation.
so
At this time, please visit the staff hubs to play today's KHHC video announcement. Don't
Okay.
go together and keeping it high.
remember,
Slogan developed to represent the
RPMs is your omega,
our commitment to
okay,
ensure excellence,
and radius is 12.
tradition,
Okay, the formula that we need, velocity equals omega times r. Okay, so that's our main relationship between linear velocity and angular velocity. So RPMs is always angular velocity, or angular speed, I guess. So we want it in miles per hour, right? That's the hard part, is converting our units from whatever we have into whatever we want. So 600 revolutions per minute times 12 centimeters per radian. Okay? So that's like the arc length. Is the radian and the arc length turn out to be that. So let's look at our units. We have revolutions, we have minutes, we have centimeters, we have radians. We want to get it to miles per hour. Okay? So maybe the easiest one is to go from minutes to hours. Right? That's pretty easy. I know that there are 60 minutes in 1 hour. Oh, geez. 60 minutes in 1 hour. Okay, there. Now I have my hours on the denominator. I'm good to go. Okay. Next, I can use a ratio to get rid of revolutions and radians. I know that 2 pi radians equals 1 revolution. So that cancels out my revolutions and my radians. Now for the hard one. I need to go from centimeters to miles. Okay? So that's my hard one, is to go from centimeters to miles. So I'm going to do a couple of steps in the middle. Number one, there are 100 centimeters in 1 meter. Okay? I know that there are 1,000 meters in 1 kilometer. And I know that there is 1 kilometer for every 0.6241 miles. So all of this is converting from centimeters to miles. Okay? And I'm sure you could ask Google or any chat bot if there was a conversion and they'd tell you, but we go from centimeters to meters, meters to kilometers, and then from kilometers to miles. Okay? So yeah, there's a lot to that one, right? The unit conversion is the craziness. So now we do everything multiplied on top, right? All of these things multiplied together, divided by all this stuff multiplied on the bottom. Let's see what we get. So we get 16.94 miles per hour. Okay? When we do everything in the numerator multiplied together, divided by all the products in the denominator. Okay, that sounds good for today. These kids are annoying. Okay, bye.